Hello and welcome to Algebra 1 Lesson 57. In this video, we're going to learn about further operations with radicals. So before I begin this lesson, I want to revisit the simplified form of a radical that we learned in the last section. So kind of the first rule that we encountered was that the radicand, remember that's your number or your variable or your expression that's under the radical symbol. Okay, so this contains no factor other than 1, which is, and then we have a perfect square in the case of a square root, a perfect cube in the case of a cube root, a perfect fourth in the case of a fourth root, and then so on and so forth. So as an example of this, I typically use the square root of 8. So if I have something like the square root of 8. At this point in algebra, we all know that 8 is 4 times 2. And we should know that 4 is a perfect square, right? It consists of 2 times 2. So this is not considered simplified because it's a square root, and one of its factors is a perfect square, right? One of its factors, again, is 4. So I can put that this is equal to, and I can split this up as the square root of 4 times the square root of 2, and I can say that the square root of 4 represents a rational number 2, right? It's a perfect square. So what they want me to do in order to simplify this is just to replace this with a 2, right? Replace it with its rational number. So I'd have 2 times the square root of 2, which I can't simplify. So there's no difference between this guy right here, 2 times the square root of 2, and the square root of 8 in terms of its value, right? Punch them both in on a calculator, you get the same thing. But if you turn this in on a test, you're probably not going to get full credit because it's not considered simplified, okay? And let me do an example with a perfect cube. Let's say we had the cube root of 16. Okay, that's going to keep it nice and simple. I know that this consists of what? 16 I could do as 8 times 2, and 8 is a perfect cube. So again, one of the factors of 16 is a perfect cube. So I would break this up and say this is the cube root of 8 times the cube root of 2. And again, this represents a rational number. The cube root of 8 is 2. So I'm simply going to write this as 2 in the simplified version, and then I'm going to keep what doesn't simplify. So times the cube root of 2. So 2 times the cube root of 2 is simplified. The cube root of 16 is just unsimplified. Again, they represent the same value, and you could go on and on when you talk about a fourth root and look for a perfect fourth in one of the factors of the radicand, right? Or you could do that with a fifth root or sixth root, so on and so forth. All right, so kind of the next thing we talked about was that the radicand cannot contain fractions. So if I saw something like, let's say, the square root of 2 over 25, something like that, this would not be considered simplified. So what they want you to do is break this up using your quotient rule for radicals. So this would be what? The square root of 2 for the numerator over the square root of 25 for the denominator. And the square root of 25 happens to be a rational number, right? It's 5. So let's just replace that with a 5. So we'd have the square root of 2 over 5. And again, this would just be the simplified version of that. Then kind of the last thing that we talked about was that there is no radical present in any denominator. So you'll recall that this was basically the focus of the last section where we learned about rationalizing the denominator. So if I had something like 2 over the square root of 7, we said that this right here was an irrational number, right? Square root of 7. So we want to rationalize this denominator. And in order to do that, I'd multiply both the numerator and denominator by the square root of 7. And so square root of 7 times square root of 7 would be 7. And I went from an irrational number, square root of 7, to a rational number, which is 7. So that's where you get rationalizing the denominator from. Then in the numerator, you just have 2 times the square root of 7. So again, these 2 over the square root of 7 and 2 times the square root of 7 over 7, they represent the same value. It's just that this one is simplified and this one is not. So if you report something like this on your test as an answer, you might get a wrong answer, you might get points taken away, your teacher might forgive you and give you full credit, but in a lot of scenarios, you're going to at least lose some points for not simplifying and reporting your answer in this way. Just like if you reported a fraction, something like 2/4, right? You don't want to do that. You want to simplify and say it's 1/2. So what we're going to do now is we're going to use all the knowledge we've gained so far, and we're just going to look at some typical problems that you will encounter with radicals. I'm keeping it very simple here for Algebra 1. When we get to Algebra 2, college algebra, we're going to look at some very, very difficult problems. So for right now, let's just keep it simple, and let's start out with the square root of 5v times the quantity, the square root of 10 plus 3v. So what I'm going to do here, because these are not able to be combined inside the parentheses here, I'm going to use my distributive property to simplify. So I'm going to multiply this times this and also times this, and we're going to see what we can simplify. So we'll have the square root of 5v multiplied by the square root of 10, and then plus the square root of 5v multiplied by 3v. Now, can I do anything to simplify here? Well, yes, I can. The square root of 5v times the square root of 10, I could write that as what? The square root of 5 times 10. Think about breaking this down completely. Square root of 5 times square root of 5 times square root of 2, and then times square root of v. Then plus. Over here, the square root of 5v, I could break that down, but really I'm not going to be able to do anything with that. 5 is prime, v is to the first power, nothing I can really do. So then times 3v. I can do stuff here because the square root of 5 times the square root of 5 is 5. So I can simply write that and say I have 5 times the square root of what's left. Square root of 2 times square root of v. We combine that and say we have the square root of 2v. Then plus, I have the square root of 5v times 3v. Nothing I can do, so I just kind of change the order, and I put 3v out in front, that's more traditional, times the square root of 5v. Now, is there anything else I can do to simplify? I want you to think back to when we added and subtracted radicals. We had to have like radicals, okay? These are not like radicals. If I look at this guy right here, and I look at this guy right here, they're not like radicals. Why? Well, they have to have the same index, which in this case they're each square roots, so that's a check. But then they have to have the same radicand. This is a 2v, and this is a 5v. Those are not the same, okay? So they're not like radicals. Where students get confused on this is they're used to looking at like terms. So if I had 2v plus 5v, those are like terms. I can combine that and get 7v. But that's not the case here. It doesn't work that way with radicals. For like radicals, you have to have the exact same radicand. So if this was 5v and this was 5v, you're good to go. But in this case, we have 2v and 5v, not good to go. So we don't have like radicals. So our simplified answer here is just 5 times the square root of 2v plus 3v times the square root of 5v. All right, let's take a look at another one. So we have the square root of 10n times the quantity 4 plus the square root of 2n. So again, I'm going to use my distributive property here. And I'm going to start out with the square root of 10n times 4, then plus the square root of 10n times the square root of 2n. So in this first case, there's not going to be anything I can do to simplify. Why? Because I have a 4 out in front. I'm just going to switch the order of that to make it more traditional. Underneath the square root symbol, I have a 10. That factors in a 5 times 2. There's no perfect square in there, right? So there's nothing I can do. Then I just have n, that's n to the first power. Nothing I can do there. So this first part here, or the part on the left, will just be 4 times the square root of 10n. Okay, nothing else I can do. Then plus. Here there's going to be something I can do. Let's completely break this down. Let's say I have the square root of 10 is 5 times 2. So square root of 5 times square root of 2 times square root of, I have that n there. Then times. Square root of 2n, I'm going to write square root of 2 times square root of n. Now, what I have here is I have square root of 2 times square root of 2, and I also have square root of n and square root of n. So what I want to do, let me report this first part. So 4 times square root of 10n plus Square root of 2 times square root of 2 is 2. Square root of n times square root of n is going to be n. So I'd have 2n there. And then what's left? Just the square root of 5. So let me kind of extend this a little bit. And these are not like radicals. And I can't simplify any further. So I'm just going to report my answer as 4 times the square root of 10n plus 2n times the square root of 5. All right, so for the next one, I have the square root of 10x times the quantity, negative 4 times the square root of 2x plus 2x. So again, I'm going to use my distributive property here. So this times this, and then plus this times this. All right, so we're going to have that negative 4 out in front times the square root of 10x times the square root of 2x, then plus, I'm going to put 2x out in front times the square root of 10x. Now, if I think about 10, again, it's 5 times 2. So I know that I'm going to have what? I'm going to have a 2 here and a 2 here. So a pair of 2's, 1, 2 comes out, right? I can kind of write it in a different way. Remember, we looked at that in the previous lesson where we first started learning how to simplify. So if I did negative 4 out in front times the square root of, I'm going to go ahead and write this as 2 times 2. I've got a 2 here, and I've got a 2 when I factor 10. And then times 5, and then times x. So I can think about it like that. And then plus 2x times the square root of 10 factors into 5 times 2. But I don't really want to do it there because it's not going to help me. Let's just leave it as 10. And then x, I'm not going to factor that. I can't do anything with that. It's just x. Okay, so then each pair here, I'm going to pull one out, right? So 2 times 2, square root of 2 times square root of 2 is 2. So for each pair, 1 comes out. And then if I have x times x here, 1x would come out. Square root of x times square root of x is x. So I'd have negative 4 times, again, one of these is going to come out. One of these is going to come out. So negative 4 times 2 times x, and then times what's left under that square root symbol, which is 5, so times square root of 5. And then plus 2x times square root of 10x. Let me scroll down here. So negative 4 times 2 is negative 8. So this would be negative 8 times x, so negative 8x. Then times square root of 5. Then plus 2x times square root of 10x. So that's going to be my simplified answer there. I don't have like radicals, so there's nothing else I can do, right? Negative 8x times square root of 5 plus 2x times the square root of 10x. All right, let's get into something that's a little bit more complex. So I have the quantity 2 times square root of 3 plus 6 times the quantity negative 4 times square root of 3 minus 2. So the way we're going to do an operation like this, we're going to use FOIL, just like when we multiply two binomials together, right? We have 2 terms here and 2 terms here, so let's use FOIL. So I'm going to do my first terms. So this guy times this guy. 2 times negative 4 is negative 8. Square root of 3 times square root of 3 is 3. So I'd have negative 8 times 3, which we know is negative 24. So let's go ahead and write that. Okay, then the next thing I'm going to do is I'm going to multiply my outer terms. So this one times this one. So 2 times negative 2 would be negative 4, and then times that square root of 3. So now I'm going to multiply my inside terms. So this one times this one. 6 times negative 4 is negative 24, and then times square root of 3. And then lastly, I'm going to do my last terms. So 6 times negative 2 is negative 12. Okay, so once I have it in this format, pretty easy to simplify. And in this case, we do have like radicals. We have the same index, we have the same radicand. So we can combine what's in the middle. So if I look at negative 4 times square root of 3 minus 24 times square root of 3, negative 4 minus 24 is negative 28. So this would be negative 28 times that common radical, which is the square root of 3. Now, negative 24 and negative 12 can also be combined. Negative 24 minus 12 is negative 36. So I can write negative 36 out in front or behind, doesn't matter. So we'd have negative 36 minus 28 times the square root of 3 as our answer. All right, for the next one, I have a similar situation. I have the quantity 4 times square root of 2 minus 5 times square root of 7k. And then this is multiplied by the quantity, negative 6 times square root of 5 plus 3 times square root of 7k. So again, I'm going to use FOIL. So first terms, 4 times square root of 2 multiplied by negative 6 times square root of 5. So 4 times negative 6 is negative 24. The square root of 2 times the square root of 5 is the square root of 10. Now I want to do my outside terms. So I'd have 4 times square root of 2 times 3 times square root of 7k. So 4 times 3 would be 12, so plus 12. Then the square root of 2 times the square root of 7k would be the square root of 14k. Then my inner terms. So I have negative 5 times the square root of 7k multiplied by negative 6 times the square root of 5. So negative 5 times negative 6 is positive 30. And the square root of 7k times the square root of 5 would be the square root of 35k. Then I want to end by multiplying my last terms together. So negative 5 times the square root of 7k times 3 times the square root of 7k. So let's do negative times positive is negative. 5 times 3 is 15. Okay, 15. But then I've got square root of 7k times square root of 7k. That's going to give me 7k. So really I'd have negative 15 times 7, which is negative 105 times k. So what can I simplify here? Well, the answer to that is nothing. This is 14k. This is 35k. That's not the same. These are not like radicals. Okay, very important that you understand that. So my simplified answer will just be negative 24 times the square root of 10 plus 12 times the square root of 14k plus 30 times the square root of 35k minus 105k. All right, for the next one, I want you to think back to when we saw the difference of two squares. And we know the difference of two squares looks like this. It's x squared minus y squared. And when we factor it, we end up with x plus y times x minus y, right? Those two quantities. Now, what you'll see in this case is you have this right here and this right here as the same term, and then this right here and this right here as the same term. What's different would be the signs, right? You have a plus and a minus. Now look at what you have here. You have a 6 and a 6. And then look over here. You have square root of 2 and square root of 2. Then your signs are different. You have a positive and a negative. So they throw things at you, especially on timed examinations, to kind of say, okay, well, you should recognize this pattern, and you should know that all I need to do is square this and then subtract away this squared, right? So really the answer, I can just do this in my head, 6 squared is 36, and then minus the square root of 2 squared would be 2. So 36 minus 2 would be 34, right? So that should be your answer. Again, you can do that in your head once you're familiar with this pattern. So let's go ahead and crank this out the long way, and then again, we'll do it the short way. So if I was to use FOIL here, so I'd start with 6 times 6, that's 36. And then 6 times negative square root of 2 would be minus 6 times square root of 2. Then next I have the square root of 2 times 6, so that's plus 6 times square root of 2. And then last I have square root of 2 times negative square root of 2, that's minus 2, right? Square root of 2 times square root of 2 is 2. So now again, we realize that the two terms in the middle here, the negative 6 times square root of 2 and the positive 6 times square root of 2, those are going to cancel out. And all I'm left with is the first term that we saw squared minus the second term that we saw squared, right? So it's 36 minus 2, which again is 34. And you saw me do that in my head. And the reason I can do that in my head, and you can too, is because I recognize the pattern right away, right? So this ends up being 34. And again, the quick way to do that is square the first thing, square 6, that's 36, minus the second thing squared. Square root of 2 squared would just be 2. 36 minus 2 is 34. All right, so here we have that same scenario. 8 minus the square root of 5, that quantity, times the quantity 8 plus the square root of 5. Very easy to do this if you recognize it. You just square the first guy. So if I square 8, I'd get 64. Then minus, square the second guy. Square root of 5 squared is 5. So 64 minus 5 would be 59. Right, and we can do this the long way just to verify that we get that answer, but I'm going to promise you 100% of the time you will. So 8 times 8 would be 64. The outer would be positive 8 times square root of 5. Then the inner, we'd have negative 8 times square root of 5. Then the last, negative square root of 5 times square root of 5. We know it's negative. Square root of 5 times square root of 5 is 5. So again, the two terms in the middle are going to drop out, right? Those are just going to cancel. And I'm left with 64 minus 5, which again is 59. All right, for the next one, again, we're going to utilize our special products formulas. So do you recall something like the quantity x minus y squared? All right, you should be able to regurgitate this formula at this point. It's x squared minus, right, because we have a minus there, 2xy plus y squared. So following that format here, I would have the first guy squared. So 3x squared, 3 squared is 9, x squared is just x squared. I would have minus 2 times the first guy, which is 3x, times the second guy, which is the square root of 2y, and then plus the second guy squared. So the square root of 2y squared, the squaring would just undo the square root. I'm left with just 2y, so plus 2y. So if I simplify this, I get what? 9x squared minus 2 times 3 is 6. I'd have 6x times the square root of 2y and then plus 2y. So that's as simple as I can get that. I'm not going to be able to further simplify because there's nothing to combine there. So I would just erase this here and show you I get the same answer if I did it the long way. So remember, I need to expand this if I want to do it the long way. I would say this is 3x minus the square root of 2y. And then if this is squared, I would say this is 3x minus the square root of 2y times, again, 3x minus the square root of 2y. So the first terms, 3x times 3x would be 9x squared. The outer, 3x times negative square root of 2y, negative 3x times the square root of 2y. The inner would be the same thing, right? Negative square root of 2y times 3x. So negative 3x times the square root of 2y. And then the last would be negative times negative is positive. Square root of 2y times square root of 2y is 2y. So if I combine the terms in the middle, I know that I have like radicals there, so I can do that because I have the same index and the same radicand, right? I have 2y in each case. So really I just think about negative 3x plus negative 3x, that's negative 6x. So this would end up being 9x squared minus 6x times the square root of 2y and then plus 2y. And again, it's exactly what we got right there. I just used a quicker method when we first did it, and that's the method that you should use, right? Memorize those special product formulas, and again, they're going to help you for the rest of your life, right? It's just something that's just going to tremendously speed up your processes. All right, let's take a look at another one. And for this one, I'm going to match that formula of the quantity x plus y squared. So this is x squared plus 2xy plus y squared. So exactly what we just looked at. The only difference is going to be your sign is plus in this case for that second term, right? If I have the quantity x minus y squared, everything is the same except for that minus sign right there. All the rest is the same. So if I was to do this, and I'm not going to do this one the long way just to save a little time, I would say what? The first guy squared. So if I square 5, I get 25. If I square x squared, I get x to the 4th power, right? X squared squared, keep x the same, multiply 2 times 2, that's 4. Okay. So now the next thing I want to do is I want to put plus 2 times this guy right here. So 2 times 5 is 10. Let me just go ahead and write that. So 10 times x squared times this guy, the square root of 7z. And then the last thing I want to do is put plus this guy squared. So if I square the square root of something, I just get the radicand back, right? If I square the square root of 7z, I'm just going to get 7z. Now looking at this, there's nothing I can combine here. So my simplified answer would be 25x to the 4th power plus 10x squared times the square root of 7z plus 7z. All right, so now what we're going to talk about for the remainder of this section is what to do when you have a more complex denominator that's involved and you need to rationalize the denominator, right? You don't want any radicals in the denominator, but sometimes it's not so simple, right? You might get something that's more complex. And before we start jumping into that, we have to learn about something known as a conjugate, okay? So a conjugate is formed when we change the sign of something like this. So if I have 3x plus 7, I would have 3x and I would have 7, but my sign would change, okay? My sign would change. So the conjugate of 3x plus 7 is just 3x minus 7. As another example, if I had something like 2x squared minus 5, the conjugate would be, change the sign, so 2x squared, this would become plus, and then this would stay the same. So the terms are the same, I'm just changing the sign. So if I had, let's say, x plus y as an example, the conjugate would be x minus y. If I saw a plus b, the conjugate would be a minus b. If I saw the square root of 7 plus 3, the conjugate would be square root of 7 minus 3. I'm keeping the two terms the same. All I'm doing is just changing the sign, right? It's very, very simple. All right, so now that we know what a conjugate is, let me just read this to you. So when we simplify a radical expression with two terms in the denominator and at least one is a radical, remember you can't have any radicals in your denominator, what you're going to do to get that radical out of the denominator, we're going to multiply the numerator and denominator by the conjugate of the denominator, okay? And the reason that's going to work is you're setting up a scenario of something like this. A plus B, that quantity, times A minus B, okay? You have the same terms, okay, in the first position of each. You have the same terms in the second position of each. Your difference is the sign. So what's going to happen is the middle two terms, when you do FOIL there, drop out. You know, we saw this earlier in the lesson where we talked about, you know, our special products formulas. This ends up being what? A squared, the first guy squared, minus B squared, right? The second guy squared. Very, very easy to kind of calculate that. The two terms from the middle are going to drop out, and you're going to end up with a denominator that is radical free. So let's see an example. So we'll start out with this kind of easy one. We have 8 over 6 minus the square root of 5. So I'd multiply this by the conjugate of the denominator, right? We're going to do that to the numerator and denominator. So if I think about the conjugate, it's what? Keep the terms the same. So 6 and square root of 5, 6 and square root of 5. But the sign is going to change, right? So instead of a minus, it's going to be a plus. Now, am I doing anything illegal if I'm multiplying this by this? No. This is a complex form of 1, right? 6 plus square root of 5 over 6 plus square root of 5, complex form of 1. I multiply by 1 and don't change the value, right? So this is legal. Now, in the numerator, if I multiply, I just use my distributive property, right? So I'm just going to say, well, 8 times 6 is 48. Then plus 8 times square root of 5 is just 8 times square root of 5. That's simple enough, right? I can't do anything else there. And then for the denominator, again, realize that you have that pattern where you have 6 and 6, same term. Square root of 5, same term. Different signs, negative, positive, okay? So I can use that little formula to speed up the process and just say, okay, well, I have the first guy squared. 6 squared is 36 minus the second guy squared. Square root of 5 squared is just 5. So my denominator is going to be 31. So I would have 48 plus 8 times square root of 5 over 36 minus 5 is 31. So my denominator now is radical free. And again, that's our goal here, because if we report our answer with a radical in the denominator, we're going to get points taken away at minimum, right? It's not considered simplified. All right, let's look at one that's a little bit harder. Not harder, but more tedious. We have the square root of 2a squared over negative 3 minus 5 times square root of 5a. So the first thing I do is if I see something I can simplify, I just do it, right? This really should be what? This is a squared underneath a square root. So this would be a times the square root of 2. So I should really just line this out and write it like that, right? And I can let me kind of just write it over here as a times square root of 2 over negative 3 minus 5 times square root of 5a. So let me just kind of move this down here to get us some more room. Again, if I want to remove the radical from the denominator in this case, I'm going to multiply the numerator and denominator by the conjugate of that denominator. So to get my conjugate, the terms stay the same. So I'd have negative 3, and I'd have 5 times square root of 5a. That stays the same. So let's do that in each case. What's going to change is the sign. So in this case, it's negative. So this would be positive, and this would be positive. Okay. So now that we've worked that out, a times square root of 2 times negative 3 is what? This is negative 3a times the square root of 2. Can't do anything else with that. Then plus, I've got 5 times a, that's 5a, times the square root of 2 times the square root of 5a. So I'm going to write that as the square root of 5 times 2, or 10 times a. So the numerator, nothing else I can do there. It's just going to stay as negative 3a times square root of 2 plus 5a times square root of 10a. Okay, what about my denominator? What can I do here? Well, again, we're going to use that formula. I've got the same term here and here, same term here and here. Signs are different, right? So square the first guy, square negative 3, you get 9. Then minus, square the second guy. 5 squared is 25. And then the square root of 5a squared would be 5a. So you get 25 times 5, or 125, and then a. Now, can I simplify that any further? No. These are not like terms, right? 9 is not a like term with negative 125a. Can't do anything further. So my simplified answer here is negative 3a times the square root of 2 plus 5a times the square root of 10a over 9 minus 125a. All right, for the next one, I have negative 2 over 5v to the 4th power minus 2 times the square root of v cubed. Now, what I can do before I even start, I can simplify. So negative 2 over 5v to the 4th power minus 2. The square root of v cubed, I can think about the square root of v cubed as the square root of v squared times the square root of v. Square root of v squared is v, so I can write this as minus 2v times the square root of v. So I like to simplify before I even think about anything else because it just makes my calculations easier in the end. So let me kind of drag this down so we have a little room to work. Okay, let me put this over here. And so now I want to multiply the numerator and denominator by the conjugate of the denominator. So the terms are the same, 5v to the 4th power and 2v times square root of v over, we have 5v to the 4th power and 2v times square root of v. The signs are going to be different, right? So this is a negative, this will be plus and plus. All right, so in the numerator, let's start out. Negative 2 times 5 is negative 10. So that's negative 10. And then we have v to the 4th power. Then negative 2 times 2 would be negative 4. And then times v. And then times the square root of v. Then over. Now, again, if I'm using that formula, I don't need to go through and do FOIL, right? I have the same thing here and here. Same thing here and here. The signs are different. So the first guy squared, 5v to the 4th power squared. 5 squared we know is 25. V to the 4th power squared. So v to the 4th power squared. V stays the same. 4 times 2 is 8. Then minus. The next guy is going to be squared. So 2v squared is what? That's 4v squared. Square root of v squared is v. So I'd have v squared times v, or v cubed. V cubed. So now my answer here, negative 10v to the 4th power minus 4v times the square root of v over 25v to the 8th power minus 4v cubed. So is there anything else I can do to simplify here? Well, yes, there is. Notice that you have that variable v here, 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 and here. So that means I could factor a v out from the numerator and the denominator, and I could cancel it. Now, you're going to only be able to think about the lowest exponent on any of them. In this case, that's going to be a 1, right? So if I factored out a v from the numerator, let me kind of scroll down and get a little room going. I would have inside of parentheses negative 10 times v cubed minus, from here I'd have a 4. the v is getting factored out, so that's gone. It's just v to the first power, so that's gone, times square root of v. And then over. For this guy, if I factor out a v, I'll have 25v to the 7th power minus 4v squared. Now, I can cancel this v with this v, and now my simplified answer is going to be negative 10v cubed minus 4 times square root of v over 25v to the 7th power minus 4v squared. All right, for the last problem we're going to look at, I have 3a plus 2 times square root of 3a over negative 3 plus square root of a cubed. So again, if there's something I can simplify before I start, I want to go ahead and do that. I know that this right here, if I have the square root of a cubed, really that's a times square root of a, right? Think about the square root of a cubed as square root of a squared times square root of a. This is really a, so it's a times square root of a. So let's just simplify this as 3a plus 2 times the square root of 3a over negative 3 plus a times the square root of a. Let's drag this down here to get a little room going. And we're going to multiply the numerator and denominator by the conjugate of the denominator. So at this point we know that would be negative 3 minus, right, we're changing the sign, a times the square root of a. So negative 3 minus a times square root of a. All right, so now that we've got that figured out, let's multiply. So for the numerator here, I'm going to use FOIL. It's going to make it easy. 3a times negative 3 is negative 9a. For the outer, I've got 3a times negative a times square root of a. So that's going to be negative. 3a times a is 3a squared, and then times square root of a. For the inner, I've got 2 times square root of 3a times negative 3. So that's negative 6 times square root of 3a. And then for the last, I'm going to have 2 times negative a, or negative 2a, times the square root of 3a times the square root of a. So that would be the square root of 3a squared. So I know the square root of a squared is a. So I can pull that out and make this a squared times the square root of 3. Now, is there anything I can do to simplify here? No, there's not. Right? There's nothing else I can do. I know it's long, but there's nothing I can do to simplify. So then this is over. Now I'm going to use my special products formula here. And that tells me to take the first guy and square it. Negative 3 squared is 9. And then minus the second guy squared. So then that would be a squared times square root of a times square root of a would be a. So really a squared times a, or a cubed. So my denominator becomes 9 minus a cubed. Nothing I can do with that. So I have negative 9a minus 3a squared times square root of a minus 6 times square root of 3a minus 2a squared times square root of 3 over 9 minus a cubed as my simplified answer.